Guys, welcome back to ETLQALABS. So today we will discuss about the very important concept about the data warehousing, the fact and dimension table concept, right, in the data warehousing. So as we are learning about the ETL testing, and data warehouse testing, database testing, etc. So it is very important that we understand what is the fact and what is the dimension table. And this is also there are a couple of requests that I have received from many of you that I should be covering some of the data warehousing concept as well, because wherever you go for interview as a ETL tester, they will definitely check your data warehousing concepts, right? Whether you are comfortable enough, whether you understand, the terminology in the data warehousing or not, right? So data warehousing is not database testing, right? As you know that. So data warehousing, there are a lot of concepts, how the warehouses are built, what is the purpose and other things, right? So I think I have already covered some of the session in my very initial videos that I have created related to data modeling, etc. So further to that, in this continuation of that same those concepts, today we will talk about fact and dimension table. So very obvious question that in interview they will ask what is fact and dimension table. So in this session I will try to cover each and every aspect of fact and dimension table, so your concepts will be very clear after this, right? So I think once you understand this concept, uh, you will be able to answer any kind of question, right? So it is like I will just try to show you some example also after that, right? So in within the session. So let's start, right? So what is the fact, right? So as we know that there are when we talk about data warehousing, so the database designing in the data warehousing world is altogether different. That is called the dimensional modeling, right? So dimensional modeling. Whereas when you design the database in OLTP system, that is called entity relationship model, right? So that is uh, in the OLTP system. But when we talk about data warehousing, it is OLAP, right? Online analytical processing, right? So in dimensional modeling in OLAP system, we do have concept of fact and dimension table, because fact and dimension, these are the denormalized form, right? That is what the purpose of the whole data warehousing system, right? Because they do not want to have so many tables and like we have in the OLTP system. They want to have lesser number of tables, and those tables should be covering, should be combining the data from multiple tables in the OLTP system, right? So how these tables are designed, so that is what is, the essence of this particular session, right? So the tables which are designed in using the dimensional modeling are called fact and dimension table, right? So these are the two different type of tables. Okay. So this fact and dimension tables basically has to be obviously joined together to fetch the meaningful information when you go for the analysis of a particular business, process. All right. So as you see that here I have just created, this is also called the star schema, guys. Okay. So there can be one question that interviewer can ask, what is the star schema? So you can answer here. Okay. So star schema is basically the designing of the data model, dimensional model, where the fact table is the center of is the center table, and there will be multiple dimension tables associated with that particular fact tables. All right. So if you see here very clearly, so this is dimension table, this is dimension table, this is dimension, this is dimension, this is fact table. So first of all, what is fact table, right? So fact table is the table which stores the data which are the measures, right? Measure of the particular business process. So for example, if I say, what is the amount of sale, uh, you know, for example, I have a store and then I would like to say, I have a store worldwide, let's say, right? So I would like to get the sales amount for India, right? So I will say what is the sales amount for India. In that case, the sales amount is nothing but that is measure, right? That is the measurement, right? That is the numerical value. So that is nothing but that is called the fact in the fact table. Okay. Any column which is having the amount column is normally considered as a fact in the fact table, right? So this is called fact. Order amount, right? This is again numerical value. Order quantity, this is also one of the numerical values. So this is also called as a fact, right? So this is representing the fact of this particular order table, all right? And then you also have the textual information. For example, here you see customer ID, it can be alphanumeric, product ID, salesperson ID, and state ID, right? So the fact table is the table which contains the factual data or the numerical data to represent any business process. All right. So this is called a fact table. We will see little more in detail later on. Okay. But for now, just try to understand that, right? So I will also show you the, example of that. All right. So here you see the order table is nothing but the fact table, right? So what the order table is containing? It is containing customer ID, product ID, salesperson ID, state ID, order amount, and order quantity. All right. If you see very clearly, these are the dimension tables, right? So the dimension tables are basically, um, mostly the dimension table attributes or the columns are mostly in textual information, right? So something which is giving some meaningful information to the fact to the fact table, right? So for example, if I would like to find out, as I said that the total sales are maybe in this case the total order done by the customers, right? A total order done by the customers who are, who are from a particular state. For example, in India, maybe, for example, they will say Karnataka, right? So for Karnataka state, what is the order? That is order amount, right? So that kind of information that you can face. So what you have to do is in that case you have to join these two tables, right? Because the state ID, if you see here and here, these are the common, right? So this is the foreign key and here this is the primary key in this particular table, right? So dimension table's primary key is having the foreign key relation. So referential integrity here, right? So similarly, if you see other than the measurements or the numerical fields, other than that, all the fields that you are getting here are the foreign key from the dimension tables. All right. So customer ID we are pulling it from here, sales ID we are salesperson ID we are pulling it from here, and then product ID we are pulling it from here, right? So only idea is when if I need to you know get certain business dimension or certain business related data, then I need to join these two tables. That is how we can get it, right? So for simplicity I have just taken one or two columns, but there will be multiple columns, yeah. So in the dimension table, just for simplicity I have taken this, yeah. So we will see the example also, but for now you understand that fact table is a table in the dimensional modeling which is having the measurement or the numerical data which is representing the factual information. All right. And then the dimension tables are giving the meaningful insights about that particular the fact data. All right. So for example, I will say order quantity by a particular product ID, product name, right? So for example, I have a product called, for example, mm, For example, credit card. Okay, credit card is one of the product from the bank, isn't it? So, let's take the example from e-commerce. So, product is, let's say, Philips TV. All right. So I have this TV. Product name is the Philips TV, and then what is the quantity that was sold, isn't it? Overall, globally. So what I have to do is I have to basically, sum up all this order quantity across the product, right? So in that case, I might be having multiple, right? Multiple product. So based on that, I need to just join it product ID from this table and this table, and then I have to say order by group by product name, right? And then you will get group based on the product name. Each of the products order quantity we can find it. All right. So this is how these fact tables and dimension tables are there, and fact tables are, as I said, it will contain the information. As you said, the fact tables are containing the information about the foreign key from the primary from the dimension table, and then the measurement columns are the amount columns. Okay, the numerical columns, yeah, and then dimension columns will be providing more information about that particular business process, isn't it? So this is how it is, and since this looks like a star, isn't it? So like the fact table is connected with three, four dimensions here, right? So it looks like a star, right? So that's why it is called the star schema. Okay. So when people will ask you what is the star schema, you can say that star schema is a dimensional modeling wherein the fact table is connected with multiple dimension tables, and that is how. All right, so this is how it is. Yeah. All right, guys. So I think this is what I wanted to talk about the fact and dimension tables in the star schema. Let's move further and then see, try to understand a little bit more about it, right? So as per definition, what we have talked about is what is fact table? Fact table contains the measures, right? Plus also textual information, right? For example, we are also having the foreign key, right, from the these dimension tables, right? So as a foreign key and these are the primary key, right? So primary key foreign key relationship, yeah. Fact table is having okay, and then dimension table is having only textual information. There is no numerical information, numerical column, right? There will be some exception, but those are different. But yeah, I mean that I can talk about that maybe later point of time. But for now, you understand that the dimension tables are having only textual information. There is no numerical information, numerical data. Okay, no columns. And then fact table is having less number of columns. So less number of columns, when I say, here in this case only you can see that, in this case we have foreign key from each of these dimension tables. So for example, four tables are there. The four field will be here, right? The primary key from each of these dimension tables, and then some numerical column will be there, some measurements will be there, that will also be 3 4 5, not more than that, isn't it? So this if you see that the number of columns, the fact tables will have very less number of columns, okay, overall. Here, if you see that I have taken only two, but this will be maybe 100 or 150 columns, etc., based on what are the information that that particular dimension is containing, right? So ideally, if you see that the dimension tables are having so much number of the columns, okay? And row wise, if you see that these are pretty much static in nature, right? The data which is there here, it's pretty much static. Static means, I mean, there are two kind of data, right? So one is the static or reference data, and other data is the dynamic data, or which keeps changing, right? So for example, if you see that, salesperson ID, salesperson will not be changing so frequently, right? So once you enter the data about a salesperson ID, salesperson name, and all those information, that salesperson will his identity will not be changed. So these are the reference data, all right. And then we will talk about when we talk about the fact table will have lot of data. How? Because for every product, for every customer wise, every product wise, every salesperson wise, there will be separate entry, isn't it? So this is nothing but the order table, right? So order table will be having transactional data will be there, right? How much transactions will be there? That many. So if you see that there will be so many records here, right? Because this will contain the more of all the transactions will be here, right? So this is like very dynamically changing data, because for order every order there will be one separate record. So number of rows will be more, but number of columns will be lesser here. Okay. Uh, so this is how I want to say, right? So more rows here and less rows here. Yeah, because this is not going to change frequently here also in case of customer also, right? Customer table will not be changing so frequently, right? So this is how it is, right? And then as I say, it is a vertical. The fact table is called vertical table also. Why it is vertical table? Because the data, the number of rows will be more, right? So it will be like stacking up, right? And then when you see the dimension table, it will be horizontal, because the number of rows will not be more. The number of columns will be more, right? So that's why it is vertical table. That is called vertical table. Okay. Now the primary key of this fact table. What is the primary key of this fact table? It is a combination of all the foreign keys basically. So this all four will make the primary key for this particular fact table. Okay. However, the primary key for dimension table is a surrogate key. I think surrogate key, if you don't know, maybe you can read it about. So surrogate key is nothing but it is, the kind of sequence generator, right? So it's in Oracle, you might be knowing that there is a sequence generator which keeps generating for every record, right? So this is the surrogate key. Surrogate key is a sequential number that is generated by the system. So for example, in Informatica we have something called sequence generator transformation. Okay, so we can use that sequence generator transformation. We can use the sequence generator transformation for generating the primary key for the dimension tables. Okay, so this is what it is. All right. Now, in terms of loading, very important interview question people may ask you. Can you tell me whether the fact table will be loaded first or dimension table will be loaded first, right? When the data load will happen in the ETL process, right? So obviously the ETL will be loading the data in the target system. So target is a data warehouse, right? And all these tables are residing in the data warehouse only, right? Because this is the dimensional modeling in fact and dimension table. Now they will ask you, can you tell me the ETL jobs will be loaded, which ETL job will be loaded first? I mean, which has to be scheduled first to load? So, any guess, guys? You can pause the video for a moment and then try to think, and see that whether you are able to guess it or not, right? So the question is whether the fact will be loaded first or the dimension table will be loaded first, right? So you see the fact is having the prime foreign key, and this is the primary key, right? The dimension table. Okay, so let me tell you. Okay, so guys, see, since these two tables, dimension table and the fact table. So guys, here you go, right? So since you see that this is the primary key and this is the foreign key. Now you tell me, uh, in normal, SQL, when we have the referential integrity, primary key and foreign key, in that case, uh, would you be able to enter any record in the foreign key table without entering the record in the primary key table? No, right? because this is not possible, right? So because you have already defined the foreign key and primary key, right? So for example, let me just try to show you little bit about it. Okay. So let's say I have employee table. Okay. Employee table is having employee ID, employee name, and then department ID. Okay. And then you have one more table called department table, DEPT table, and this is having DPT ID, and one more column is department name. All right. Now the thing is, let's say 1A10. All right. You have 10, 20, 10 and maybe electronics, yeah. And then here if I say to uh, sorry, this will be A, maybe name A, here B, and here maybe 20. All right. But here I do not have information, right? So this is this column, right? This will be the primary key and this will be foreign key. Okay. In normal ER modeling, right? So you know that, right? So do you think if I do not have here 20, right? Which is so will I be able to insert the data into this particular employee table? No, right? Because I need to insert first here and then this will be referenced. Whether we have the data 20 here, then only I will be able to insert this particular record. Otherwise, it will say the referential integrity error, right? So, so what I have to do, I have to actually insert the data into this primary key and then after that foreign key table. All right. The similar way here, the dimension tables will be loaded first. Okay. Once the dimension tables are loaded first, and then after that the fact table will be loaded. So all the dimensions will be loaded first. The data will be populated here. The ETL jobs related to dimensions will be run first and completed, and then the post condition of that particular job, it can trigger the job related to the fact table loading. All right. So this is the very important question that they might ask you, and you have to understand that, and you have to give the logic behind it, right? The way I explained you here, right? The primary key and foreign key relationship and the data loading, right? All right, guys. So this is what I wanted to cover. Okay, one more thing is so as I said you right in the previously that I will be giving you some example, right? So what kind of analytical queries will be there, for the process because the data warehousing or OLTP system, OLAP system is mostly for the analytical purpose of the data, right? So we have to fetch the huge amount of data, right? In this case, for example, if I want to find out the, you know, sales amount or the order amount probably, okay? Order amount in our case, order amount by state name, right? So I have, let's say in India, we have only, for example, we are considering the India as a sales region. So we have so many states, right? 30, I don't remember. Yeah. So those many states are there. All those states uh, will be having the sales, right, for a particular year. So in that case, if I want to find out the overall sales data for that particular year, in that case, what I will be doing is I will be actually using these two tables, joining these two tables, right? So in that case, I will be using the, sum of the order amount, and in this case, we want to know the order amount by state name. So I have to join these two tables, right? So these two tables, and then I have to do the, group by state name, and obviously the joining will be there on a state ID, right? Here, state ID here and here. So joining these two table, inner join and then order by state name, right? This is how I can get it. Similarly, if I want to get the data based on, salesperson wise, isn't it? Salesperson wise, I can join these two table and then salesperson name, order by group by salesperson name, I can do that, right? So joining these two tables. So this is how I can do. And similarly, if I need to, get more granular data, probably let's say if I need to, Let me think. Yeah. So, okay. What I can do is, so let's say if I want to get the, the order amount, okay, by customer name, by salesperson, and then also by the, by the customer name, right? So how it should be, maybe order amount, okay, sum of order amount, probably I'm just showing you, and then customer name, and probably here I will say the salesperson name, right? Salesperson name. So if I need to get the data, then I have to join these three tables, right? One is the fact table here, the fact table, and something like this I can write, isn't it? I mean, basically, I can just join this table. I will say customer ID equal to customer.customer ID equal to order.customer ID and order.salesperson ID equal to sales.salesperson ID. They are the two joining condition that I have to put, and then I have to say group by uh, you know uh, customer.customer ID comma sales.salesperson ID, isn't it? And but here I am going to just say sum of the order amount, isn't it? So something like that I can write. So the query might look something like this. Select, right? Just see that. Select order amount. All right. Mm, better I can just try to write it here. It will be helpful. All right. So it will give you more information. That is the reason I'm writing it here. Customer dot customer name. All right. And then I will say salesperson dot sales salesperson name. All right. I mean, I'm not writing the exact column name, guys, but you just understand this, right? So sales person name. Okay. From these three tables I have to say, right? So order, customer, and what else? Salesperson, right? Salesperson, where I can say order. Let me just write in the other line. Okay. Where order dot salesperson uh, salesperson ID equal to you know salesperson ID, guys, and then I have to put end condition, then again order dot what is that? I have to join this customer ID, right? Customer ID, and then customer dot cust ID. Correct. And then I have to say group by, isn't it? Because I have to group the data, right? So I have to say group by salesperson dot salesperson name and comma customer dot customer name. Correct, guys? So this is how I can write the query, right? And this will give you the information like, order amount and then based on the customer and then salesperson corresponding customer name. So you can actually join multiple tables, right? In this case, we are just trying to join these two tables with this, right? So this is very easy because these two dimensions doesn't have anything commonality, right? No columns which can be joined. But the fact table, the beauty of this, dimensional modeling or the star schema is that all the, dimension tables are having the primary key with your, the fact table. So you can always join anything you can join, but you have to use this a master key, right? So this is the master table. All right. So yeah, guys, I think I have tried to cover most of the things now. I think this will really make sense and it will be helpful for you to clear the interview. Lot of concepts, so just try to understand this. Yeah, these are the basic, and I'll come up with more videos. I think data warehousing concepts because I'm getting lot of requests from some of you that the data warehousing concepts need to be, you know, need to understood more or need to be covered because this is the very obvious and basic question that any interviewer will ask. Even if you're going for 2 years or 2 to 3 years, then also they will be asking this question. Okay. Okay, guys. So I think this is what I wanted to cover everything. Okay. If you need some more information, please comment on my video, and I will be able to make videos related to whatever your queries is, right? But this is what I wanted to cover in this session, and bye for now then, and until I come up with the next video. Happy learning.